In this section, I would like to introduce the idea of privacy by design, where we talk about the importance of integrating privacy protecting measures during the design phase of the IoT applications. Before I go into the details, I would like to remind you the complexities of the IoT application design process. So in these figures, I have put the desktop applications, mobile and web applications. So the differences are that in the desktop applications, the user interface and the processing both happens within the desktop machine. In a mobile applications, the UI or the user interactions happens within the mobile phone, and then the computation probably happens maybe most of the time within the cloud, and then maybe a little bit about within the mobile phone as well. In the web applications, you have the UI sits locally, and then the entire processing happens behind the scene in the cloud. So these are the three variations. And then when you talk about the IoT, it's pretty much have the mix of all three. It has mobile applications in a particular IoT system. It sometimes have the desktop applications as well, but it certainly have the web applications. And then you have the hardware devices and resource constrained devices such as microcontrollers or single board computers. So all these hardware and software components need to come together in an IoT system, which means there are a lot of different components need to be designed in a way that they work together. And also the communication between these components are not straightforward as mobile or a web, because in a mobile or web, you will pretty much communicating with the server. So you know that how you are going to communicate with either 3G or direct Wi-Fi, but IoT brings a lot of other protocols, both communication technology level as well as application level. So when these different components are bringing together or glued together with different protocols, there are a lot of servers to cover. There are a lot of design decisions to be made. So we already talk about in entire lesson in human factors, the importance of making right design decisions during the design phase. But over the next few slides, I'm going to talk about the importance of integrating privacy protecting measures into all of these different design processes. Privacy by design scheme is basically a bunch of ideas combined together as a list, where each of the elements within these schemes or the list contribute to protect privacy in a unique way. So there are many different terms we use to identify these privacy by design schemes. Roughly speaking, each of these terms have some relationship with the abstractness or the level of details of the idea it presents. For example, when you say privacy foundation principles, they give a little bit higher level ideas. If you want to implement a privacy principle, you probably need to think about your own ways to implement it. Then privacy design strategies are somewhat more granular, more specific. You can a little bit easily implement it. And privacy guideline is again much easier than privacy strategies. And then privacy patterns are very specific. So the idea of patterns come from software design patterns, which we all know, where they are designed to solve a specific software development problem. So privacy patterns are very similar. So they are designed to solve very specific problem. So if you have the same problem, you can basically implement the particular pattern. And then the privacy tactic is a very specific. So within the pattern, you probably could have multiple options to like tweaking things to make it more concrete. So privacy tactics is where it helps to change the patterns in such a way that it fits within your particular IoT application design. So what we here see is that the top layers are quite abstract. How to implement is something that the developers need to think a little bit. And then when you go down, they become more and more specific. And then it becomes very narrowed down and clear on what kind of problems it can solve and how to implement them. So over the years, many institutions and researchers have come together to develop all of these different privacy by design schemes. As I mentioned before, principle is a high-level concept which outline a value that is a guide for a behavior or evaluation. So typically they are abstract, provide an overall directions to follow. Here I have listed a couple of privacy by design schemes that propose different types of privacy principles. So the next one is privacy by design strategies. So in contrast to the principles, strategies focus on achieving very specific outcomes. Design strategies describe a fundamental approach to achieve a certain goal. Here I have cited one of the well-known privacy by design strategies, which are quite useful within the IoT systems design as well. Then we have privacy guidelines, which are much more granular. So you can think of as more granular than strategies. And what they have done is they have taken each of these strategy and then divided into different guidelines, where when you comply with each of these guidelines, it will automatically follow the strategies. We will be talking about these strategies and guidelines with examples at later in this lesson. Here I have given example for one of the privacy by design guidelines within the context of IoT. As I mentioned before, patterns are the next level of privacy by design schemes. People have developed design patterns for various different reasons in software development domain. So in this case, we are talking about specific patterns that can be used to solve specific privacy issues, or patterns that help to reduce specific privacy risks. So here I have listed a privacy by design scheme that proposes a number of different privacy patterns which you can look up to solve your own privacy problems in your IoT applications. It is worth noting that in relation to privacy patterns, there are also something called anti-patterns. Anti-pattern is something that you should not do. So people have looked into past software development projects or approaches, and then they have figured out that certain way of doing things are wrong, or it creates more problems. So they have extracted those ideas and have created patterns and telling the people not to follow them. So those are called privacy anti-patterns. So the key thing to note here in patterns, they are basically take it or leave it approach, which means that if you have a particular problem that and if there are a particular pattern that address that problem, then you can just grab it. But otherwise, it is not a generic enough idea for you to take it and change it quite a lot. So that is the whole point of a pattern, which solve a very specific problem. Then we have the tactics. So patterns are built from tactics. So you can think of like if a pattern is a molecule, the tactic is an atom. Or in other terms, patterns package multiple tactics together to solve a specific problem. At the same time, tactics help to fine-tune the patterns. Typically, they address a specific quality attribute or a trade-off decision. So far, we went through a quick tour of privacy by design schemes. When we use the term privacy by design scheme, we broadly refer to 5 types of frameworks: principles, strategies, guidelines, patterns, and tactics. Over the next few slides, I would like to talk about 3 different schemes which are quite popular. First, I will talk about the initial privacy by design principles. They call foundational principles. Then I will be talking about privacy by design strategies. And then I will talk about privacy by design guidelines. All of these frameworks look at privacy risk and privacy preserving mechanisms from different angles. But they have a single objective, which is to help software developers and system engineers to think about how to apply different techniques to protect the privacy of the end users. The initial ideas of privacy by design, they call privacy by design foundation principles, were proposed by Anne Cowockian, who was the privacy commissioner of Ontario, Canada. Later, these ideas were framed as a privacy by design framework in 2009, and then they were again revised in 2010 by the privacy commissioners of data protection authorities. Altogether, they have 7 principles, and let me go through each of these privacy by design foundation principles one by one. First principle is called proactive, not reactive, and then preventative, not remedial. So what does this mean is that when you're developing an IoT system, you should proactively take measures to help users to protect their privacy. So this could be like forcing them to change the password after initial configuration. So you don't have to wait until late something bad happen or systems compromised to force them to change password. You should immediately after the initial configuration should force the end users to change the password and block them using the system until they change it. So this is one of the examples of proactive measures. And then you could think of a lot of different ways to achieve this proactiveness. So that is the whole essence of these foundation principles. They are quite abstract, so it gives the direction, but the software developers or the systems engineers actually need to follow them. So that is why I initially said that sometimes they are not necessarily easy to follow, because you need to do the hard work of thinking about how to exactly implement them in the IoT system. The next one is privacy as a default setting. So basically you have seen some configuration panels in previous sections related to activity tracker devices. So when you are allowing them to set something, you should set everything into the least privacy risk options. So perhaps like data sharing only to the end user, rather than start with saying, okay, the data is can be seen by your friends or family. No, so at the beginning you should configure them to seen only by the user. So if the user like to share the data, they can go and later change it to family or friends. So this is again one example, but you can think of similar settings. comes as the default. Or you can also think about like opening different ports and enabling certain communications or backup data storages. So these things could be features, but they should not be enabled by default. So opening a particular port or some kind of a communication initiation should be something that explicitly done by the end user if they choose to do so and if they do understand what are the consequences. So the default setting is switch off these additional features that could potentially violate privacy. The third principle is to privacy embedded into the design. So what does it mean is that when a typical software is developed, you usually collect the requirements and then they do the design by the developers, and then it go back to the clients, and once they approve, perhaps the development team start developing. And then adding privacy means that once these design happen, then just before the development or during the development phase, somebody tries to add some privacy protecting features. But what this principle says is that you need to think about privacy or protecting measures while you are actually designing initially. So there has to be someone represent from the privacy or the privacy by design angle who look at the design during the design phase, providing advice to the team saying how to embed privacy protection measures into the design itself, and get it confirmed before you go to the development, because then developers can't miss it because they have to implement this. But if you pass on the responsibility of privacy protection to the developers, because of the other pressures about the time or performance of the system, they will be focusing on other things rather than privacy, and then privacy become a secondary consideration. So the ideal version is that you embed all the privacy by design principles and techniques that you need to be implemented during the design phase and get it signed off by the clients as well as the architects, and then go to the development. The fourth principle emphasizes the fact that privacy should not be viewed as a zero-sum approach. Instead, it should be looked at a positive-sum approach, where it creates a win-win approach for everyone. For example, sometimes people think that you should not collect a particular type of data if you want to protect privacy, which is not correct. So if you want to come up with a particular insight, you might want to collect certain type of data. However, the idea is that you should collect the data, the only the amount of duration as well as sampling rate. So you should not collect data more than necessary. So that is what the privacy means. It is not about not collecting, but collecting within the limitations and within the limitations of what you need to achieve. This goes to any other trade-offs as well. So if you want to use a camera, perhaps you can use a camera, but the question comes, what kind of quality of the camera? How much frame do you need? What kind of data that you need to send to the cloud? Do you need to send data to the cloud all the time? So privacy doesn't stop you by collecting data, but it is important to ask the questions about the type of data you collect, the value process, and all the other information. So you think about the privacy while you are trying to achieve the objective. And then you may also think about the potential compromises. For example, if your objective is to detect activity using the wearable sensors, what kind of granularity or the resolution that you need to collect the data in order to identify the activity. And then if you collect more than you need, for example, very high resolution data, which means very high frequency, perhaps it will potentially lead to privacy violations if the data get leaked, because somebody might be able to develop algorithms that could use these very highly precise and high resolution data to determine particular health conditions of an individual. So you need to gather the data in the minimum possible way to achieve the task at hand. But it doesn't mean that you don't have to completely stop collecting data. The fourth principle is end-to-end security of the full life cycle protection. We already talk about this quite a few times. When you talk about life cycle, you can talk about the data life cycle, and also you can talk about the product life cycle. The data life cycle starts from the point that you capture the data and then you delete the data. And then the product life cycle could start from you initializing your IoT device, inputting your personal information, configuration, and then you are throwing away the device after they are broken or after you are replacing it. So you need to think about how you are going to format and delete the data that you maybe have in your storage in particular IoT systems. Then you have the next principle called visibility and transparency. We already talked about the importance of transparency, explaining the end users why you are collecting particular type of data, who is going to process, how long you are going to keep. So all this information typically something that go for terms and conditions. Ideally, there has to be better ways to communicate those kind of information with the end user. So the end user are always informed about what is happening. We already talk about some of the use cases where the breathing machines that they share the data with the insurance people without even telling. Even though legitimately they might have the authority to do so, saying, okay, we funded the devices, so we might be able to do that. But you need to have the consent of the end user to do that. So it is important to keep it open and keep it transparent with the end users and tell them exactly what kind of data you collect and what you're going to do with them. The final principle is respect for user privacy and keep it user-centric. So this is connected to some other principles as well. For example, default setting or transparency and visibility. So sometimes you need to think about that the end users may be not tech savvy. So they, even though you might provide a lot of granular options to configure the privacy requirements, they may not be able to actually use it. So you could help them and develop technology to help them configure their IoT devices properly and make sure that you have some kind of secondary mechanisms that kick in if you feel like the particular end user, based on their behavior and maybe the personal characteristics of the age or living conditions, they may not be able to comprehend what exactly they are doing. So you can have like secondary nudges asking, are you sure you want to do this? Or explain maybe the consequences. So the whole idea is to keep it user-centric. So you think about the users' expectations rather than your own goals in terms of collecting data, or maybe you are getting your advertising revenues up. One concrete example for respect user privacy could be something like this. Think about an IoT system which has multiple functionalities, which has basic functionalities as well as some advanced and complex functionalities. So the advanced and complex functionalities might require data analytics need to be happen on the cloud. Maybe they need to have capture more additional sensitive information like behaviors or activities. So one approach is to say that the end user need to release all the data and agree to all the conditions. Otherwise, the system will not work at all. The more better or the privacy respected approach is that you follow a granular approach where at the minimum there will be certain functionalities will work up to certain accuracy and certain reliability. and then be honest with the end user, and then if the certain functionalities, in order to perform certain functionalities, if you need to send the data to the cloud, be upfront about it and explain to the user, and then try to get the consent. If they don't consent, then don't push them to accept it. Don't block the other functionalities. Let them use the other basic functionalities rather than enabling advanced functionalities. So giving these choices of control, and rather than tricking them to accept certain conditions, so you can gather the data you need for your business purposes. So this is one concrete example. There could be a lot of other ways that you can respect privacy and have a honest interaction with the end users. This is a quite dense slide, which I'm not going to discuss in detail. But what you are seeing here is that 1 to 30 are privacy by design guidelines. And then these categories, you can see here color-coded categories. They are the strategies. So privacy by design strategies. So I previously mentioned that strategies are quite high level, and then guidelines are where that each strategy are taken and then divided into multiple more granular, easy to implement privacy protecting measures as guidelines. So there are 8 different privacy by design strategies, and then 8 of these are divided into 30 different guidelines. So if you want to see the details, I would highly recommend you to look at the original references. When I was introducing the privacy by design schemes, I put the reference for both of these strategies as well as for the guidelines. Please go and study them in detail, because these privacy guidelines are specifically designed to help IoT systems design. We have now reached the end of lesson number 6, privacy and security. I hope this lesson helped you to understand what are the security and privacy risks, and the techniques to avoid or mitigate those both privacy and security risks. I also hope that you understand the importance and the gravity of the problem of or the challenges of security and privacy in the context of Internet of Things, which would ideally motivate you to take necessary measures when you are designing an IoT system.